The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Well, I've got good news or bad news, depending. I haven't looked at your test scores yet, but if you mastered factoring, then I've got good news. If you didn't master factoring, I've got bad news. The news is this: we're going to continue to be using factoring as we go on into Chapter 7. We're going to take a look at Section 7.1 and Section 7.2 today. So let's go ahead and get started. All right, so this is Section 7.1. And this first problem says, evaluate the expression for x equals 6. And the expression is 3x minus 2 over x minus 2. So what we're going to do is we're going to take this rational expression, basically an algebraic fraction, a fraction with at least a variable in it is called a rational expression. And we're going to replace all the x's with 6's. So we've got 3 times 6 minus 2 over 6 minus 2, 18 minus 2, which is 16 over 4. Final answer is 4. So evaluating this expression for x is 6, the answer is 4. Any questions about that? All righty. Let's take a look at another one. Same thing, evaluate the expression for x equals 6, only now this is the expression, x squared minus 36 over x cubed minus 1. So we've got 6 squared minus 36 over 6 cubed minus 1. Well, 6 squared is 36. So in the numerator, we've got 36 minus 36, which is 0. Let's see, 6 cubed, I think, is 216. Let's see, 6 times 6 times 6, yeah, 216. Minus 1 is 215. But what's 0 divided by anything other than 0 divided by 0? It's 0, right? So this expression evaluated when x is 6 gives us 0. Any questions about that one? All right. Third expression. Again, we're going to evaluate this expression for x equals 6. And the expression is negative 2x squared minus 3 over x minus 6. So in the numerator, we have negative 2 times 6 squared minus 3, which is negative 2 times 36 minus 3, which is negative 72 minus 3, which is negative 75. And in the denominator, we have 6 minus 6, which is 0. What is a non-zero number divided by 0 equal to? Do you remember? It's undefined. So you can't divide by 0. It's all fun and games till somebody divides by 0. Then the universe collapses. Okay, so 0 divided by a non-zero number equals 0. A non-zero number divided by 0, we say, is undefined. All right, now, new set of directions. It says, find all real numbers for which the rational expression, so that's a fraction with variables in it, is undefined. Okay, so And let's take this one, 15 over x minus 2. So find all real numbers for which the rational expression is undefined. When would this expression be undefined? When the denominator is 0. Okay, so if we had like 15 over 0, that would be undefined. So when would that equal 0? Well, when x is 2, right? Because then we have 15 over 2 minus 2, which is 15 over 0. So find all real numbers for which the rational expression is undefined. 2. You all right with that?
Yes, I am.
Okay. How about this one? Same directions. Find all real numbers for which the rational expression is undefined. So when is it going to be that? Well, when that equals 0. And when is that? When x equals 0. Because if x is 0, 6 times 0 is 0. The denominator is 0. So the answer for that would be when x is 0. Okay?
Okay.
How about this one? So find all real numbers for which the rational expression is undefined. So when would that be 0? Never.
Really?
What if x is positive? What's positive squared? What's a positive number squared? Positive times positive is positive, right?
Yes.
What's positive plus 4? Is it 0?
No.
No. Okay. Let's say x is 0. What's 0 squared?
1.
0 squared?
No, it's 0, isn't it?
Okay. What's
Yeah,
0
I was like,
plus
no, wait.
4? Yeah. What's 0 plus 4?
4.
Okay. So it's not 0, is it? Let's take a negative number. What's a negative number squared? A negative number times a negative number is a
Positive.
And what's positive plus 4? Positive. So there's no value of x that would make this thing equal to 0. Okay?
Okay.
All right. Now, new set of directions. Good morning, Antonia. Simplify. 45.
Good morning.
How are you this morning?
Good, thank you.
Excellent. All right, simplify. So basically, we're reducing a fraction, 45 over 9a. We can divide the top by 45, or excuse me, by 9 and get a 5. Divide the bottom by 9 and get a 1. So now we've got what? 5 over a. You do a very good job of crossing those out. All right, with that?
Yes.
Okay. How about this one? 9x cubed over 6x. So we could reduce the 9 over 6 to 3 over 2, dividing the top and the bottom by 3. X cubed over x would be x squared. So we get 3/2 x squared, or 3x squared over 2, either way. You okay with that? I'll take that as a yes.
Yes.
All right. Now, let's say we had 4 times 12 over 8. Could we simplify that by reducing the 4 over 8 to 1 over 2? Could we do that?
Yes,
I think in order operations, could we do it?
Yeah. Okay. Could we reduce the 12 over the 8 instead?
I think we can.
You are correct. Now, here's the real test. In that problem, can we reduce the 4 over the 8?
No.
Why not?
Because you have to add first.
Yeah, because this 4 over here, this 4 is a factor, right? They're being multiplied so we could reduce it. But here, you'd have to add them first. So you couldn't say, well, 4/8 is 1/2 and then go from there. That's wrong. Okay, now keep that in mind. Let's say I've got this problem. 4x plus 12 over 16, and the directions say simplify. So my question is this: can I reduce the 4x over 16? The answer is no, for the same reason it was no here, because this is not a factor of the entire numerator. Okay. Likewise, I can't reduce those because 12 is not a factor of the entire numerator. However, I could do this. Now, the 4 in the numerator is a factor of the entire numerator because it's 4 times everything up there. So now I can come in and make this into a 1/4 and write my final answer like that. Okay, you can reduce common factors on top and bottom. You cannot reduce terms. If the factors are factors of the entire numerator and the entire denominator, you can reduce them out like we did here and here and here and here. But if they're not, then you can't. Okay. So what did I do? I factored the numerator, took out the greatest common factor so that I could reduce it down. So here we are, still factoring. Okay. How about this? 2x minus 14 over x minus 7. The 2x is not a factor of the entire numerator, nor is the minus 14 a factor of the entire numerator. But I could rewrite it like this. Now, the quantity x minus 7 is a factor of the entire numerator, and the quantity x minus 7 is a factor of the entire denominator, and I can reduce those down, and my final answer is just 2. But I can't come in and say, oh, let's reduce that down to 2, and let's reduce that down to 2, and 2 minus 2 is 0, and wrong. Can't do that. Okay? And that's the big deal in this chapter, is recognizing when you can reduce something because it's factored, when you can't reduce something because it's terms. Be okay with this example?
Yes.
Yes.
Right? Let's turn up the heat a little bit. Here we go. Y squared minus 25 over y squared minus 3y minus 10. Y squared, those can't cancel out or reduce out because they're not factors of the entire thing. I can't take 25 over 10, but what I can do is this. I can factor the numerator as the difference of 2 squares. I can factor the denominator. Okay. Now I can come back and reduce out the common factors of the numerator and the denominator, and there is my final answer. But I can't reduce those 5s and or those y's, excuse me, slow down, Rail. Can't reduce those y's in the final answer because this y and this y, they're not factors of the entire thing. But this y minus, oops, this y minus 5 and this y minus 5, those are common factors. Okay. You getting this so far?
Yes.
Yes.
All righty. How about this one? 11c squared minus 11d squared over c squared minus 2cd plus d squared. Well, in the numerator, first I'm going to factor out the greatest common factor, which is 11. Then I'm going to factor the difference of 2 squares. In the denominator, this is a perfect square trinomial. Okay. And I'm not taking time to do the all the steps to factor it, because that was last chapter. So are we okay so far?
Yes.
So now I can reduce out a common factor. So my final answer is that, or that. And look at the instructions in WebAssign. If it says you can leave it factored, you can stop here. If it says to multiply it out, stop there. Okay. If it doesn't say anything, they should accept either one. All righty. Okay. How about this one? 6 times d plus 3 minus 6 over 7 times d plus 3 minus 7. Could I reduce out the d plus 3s?
Yes.
No.
We can.
They're not factors of the entire numerator.
Oh, yes, 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 you're right.
Yes. I know. Gotcha. Okay. Here we go. Okay. 6d plus 18 minus 6, 6d plus 12. 7d plus 21 minus 7, 7d plus 14. But I could factor a 6 out of the top and a 7 out of the bottom. And now I can reduce those out. Okay, so you see, I had to get it in factored form, the whole numerator and the whole denominator factored to be able to reduce out common factors. These are not factors of the entire numerator or the entire denominator. So again, watch out. All right. Okay. What's 7 minus 3 over 3 minus 7? Well, let's see. What's 7 minus 3?
4.
What's 3 minus 7?
-4.
What's 4 divided by -4?
1.
Negative
-1.
-1. Okay. What's 10 minus 2 over 2 minus 10? What's 10 minus 2?
8.
What's 2 minus 10?
-8.
What's 8 divided by -8?
-1.
Okay. Let's see. What's x minus 3 over 3 minus x?
-3x. No, that would be
Okay, we're not ready yet. Let's back up.
But
What's 15 minus 3 over 3 minus 15? What's 15 minus 3?
12.
What's 3 minus 15?
-12.
What's 12 divided by -12?
-1.
Are you seeing a pattern?
Yeah.
What's x minus 3 over 3 minus x?
X over negative X? Or no?
It's -1.
Oh, yes. They're all the same.
There you go. What's dog minus cat divided by cat minus dog?
1.
No, it's not 1.
What is it?
-1.
-1. You seeing it? So basically, in all these cases, the numerator is the opposite of the denominator,
Oh, yes.
even this. So a number divided by its opposite is -1. Okay.
Mhm.
So what's t minus 9 over 9 minus t?
-1.
What's 4x minus 7 over 7 minus 4x?
-1.
I think you've got it. Okay, here we go. What's 18 minus d over d minus 18?
-1.
-1. Now be careful. What's 5t minus 1 over 3 minus 15t? Well, it's not -1. However, watch this. I can factor that to look like that, okay?
Okay.
What's this right there?
1.
What?
That would be -1.
-1. You were being too positive. You need to be negative. -1. Okay, so this over this is -1. So I've got -1 over 3 because that 3 was still there. Okay.
Okay.
All right. Remember, the answer is -1, not +1. Okay. I'm sorry. I'm having too much fun. This is math. I'm supposed to be very solemn and well, okay, here we go. All right. 4 minus b squared minus 5b plus 4. Okay. Okay, so far so good.
Yes.
What's that?
-1.
Aha. So this becomes -1 over b minus 1. Okie dokies.
Yes.
Yes.
All right. 36 minus 6h over h squared minus 36. So let's factor a 6 out. We get 6 minus h. The difference of two squares, x or h plus 6, h minus 6. What do you see?
-1.
Right
Mhm.
there. So what have I got now? I've got 6 times -1 is -6 over h plus 6. I think you've got it. By Joe, I think you've got it. I don't know who Joe is, but you've got it. Or is it by Jove? Okay. Now, take a look at this. Let's see how much time we got. We're doing well, doing well. Let's see, plus. So that's x squared minus x minus 2. It says simplify. If the expression cannot be simplified, write does not simplify. Which one of you wants to just look really brilliant? Any volunteers? Who wants to be brilliant? Okay, tell you what, either one of you. When I ask a question, the answer is going to be factor it. Okay, so are you ready?
Okay.
Okay,
Yes.
how are we going to reduce this?
We're gonna factor.
That didn't sound very, very confident. Let's try it again. How are we going to reduce this?
Factor.
Accurate.
Brilliant, brilliant. Here we go. Let's see, plus 3 and minus 2. And that's going to be minus 2 and plus 1. You okay so far with that?
Yes.
And you're thinking, factor it. No, not that. Yeah, right. So this reduces down and we're left with that. And we can't reduce those x's because the x's aren't factors. Just the x alone, right?
Yes.
Okay, so factor it, reduce out common factors, bada boom, bada bing. All right. How about, let's see here. Let's do this one. 2x squared minus 8 over 3x squared minus 5x minus 2. What are we going to do first?
Factor.
Accurate.
Brilliant. Okay, we're going to factor out a 2. Then we're going to factor the difference of two squares. Factoring the bottom, let's see, a is 3, b is -5, c is -2, the product is -6, the sum is -5, the numbers are -6 and 1. So we've got 3x squared minus 6x plus 1x minus 2. Factor by grouping 3x, x minus 2, x minus 2 plus 1. And I know I'm going a million miles an hour, but I just need to get to that. What factors out? What do I get rid of?
The 2s. The
X
X
minus two.
minus 2.
There you go, the X minus 2s. So I've got 2 times X plus 2 all over 3X plus 1. And again, you could write it that way, or you could distribute that 2 on top if they ask you to. Otherwise, that's fine, either one. Okay.
Okay.
All right, we're going on to section 7.2, just like that. Let me remind you how you do arithmetic. Okay, let's say you've got that. You're multiplying two fractions together. You have a couple of options. One, you can multiply straight across the numerator and the denominator, and then take the results and reduce it down, right?
Mm-hmm.
Or you can, as we call it, pre-reduce and get to the answer. Okay. And in arithmetic, it's not so bad if you don't pre-reduce because, you know, 4 over 6, no big deal. But in algebra, we definitely want to pre-reduce. Okay. Now, when you can, let's say I've got 2/7 times z over 3. Is there anything I can pre-reduce?
No.
No. So there's my answer. Let's say I've got this. 11m over 21 times 14 over 55m cubed. Here I can, and therefore I will pre-reduce. 14 over 21 is 2/3. Okay with that?
Yes.
11 over 55 is 1/5.
Mm-hmm.
M over m cubed would be 1 over m what?
Square.
Good. So 1 times 1 times 2, 3 times 5 times m squared, 15m squared. Final answer. All righty,
Yes.
good to go on?
Good. Yes.
Okay. Oops. All right. 3y minus 9 over y minus 3 times y over 3y squared. Okay. What should I do first?
We could do
You've forgotten already? Come on, come on.
factor.
What?
No,
Yes!
we could have
What are we gonna do first?
Okay.
factor.
Factor.
Okay.
Brilliant, brilliant. How quickly they forget. All right. So here we go. This is 3 times y minus 3, right?
Yes.
So now I can get rid of the y minus 3s. Okay. That
Yeah.
becomes 1 over 1. I can reduce the 3 over 3 to 1 over 1. I can
Mm-hmm.
reduce the y over y squared to 1 over y. What have I got left on top?
1.
And on the bottom?
Y.
Because I asked you. That was really, I know, my jokes get dumber and dumber as I get older. And I'm really old, therefore my jokes are really dumb. Okay, we good with this?
Yes.
Okay. Go on to more fun. Fun for whom, you say? Well, it's really fun for me. What are we going to do first?
Factor.
Excellent. Oh, this goes. I see some doggies and kitties. Do you?
Yeah, I do too.
So -1 over 1.
Mm-hmm.
5 times -1 times 1 is -5. Z plus 2 times 1 times 1, z plus 2.
Mm-hmm.
Just like that. Okay. Let's see here. How about this one? 9p times 10 over p. What's the implied denominator of the 9p?
1.
Right.
P.
1. So this p is in the numerator, this p is in the denominator, right?
Mm-hmm.
So we could cross out the p's and we'd have 9 times 10 is 90. Okay with that?
Yes.
Now, let's go back to arithmetic. What do you do when you're dividing by a fraction? What do you change it to?
The common denominator?
No, that's
You
when you're adding. or
flip it, don't
subtracting.
you?
What do you do?
Flip it,
Flip which one?
the second term,
And what else do you do?
and then multiply.
All right, so dividing by a number is like multiplying by its,
Reciprocal.
good job, reciprocal. Okay, or as I like to call it, refliprical. So then you can reduce 4/2, 2/1, final answer, 2/3. Okay. So far, so good.
Yes.
Yes.
Here we go. 3 divided by a, all divided by 9 divided by 5. So this becomes 3/a times 5/9. What can I do now?
Reduce.
Yep. And I get 5/3a. Or for Canadian, 5/3, eh? All right. Okay with this?
Yes.
Yes.
How's about this one? 3x plus 6/40 divided by 3x squared over 24. And now be careful. Now be careful. What are we going to do first?
Factor.
Factor.
Oh, that's why I said be careful. No, what are we going to do first? New correct answer.
Add.
No.
No. It's divided.
So what are we going to do first?
Reduce.
No. I mean, you could, but we're going to change it to multiplication of the reciprocal. Okay.
Okay.
And now we're going to,
Factor.
yes. See, that's the clue when I do that, when I look like an idiot. Okay, so this is what? 3 times x plus 2/40 times 24/3x squared. Okay. All right with that?
Yes.
So now I can come in and let's see. 3/3 is 1/1. And I could have taken the 24/3 and turned it into an 8, but I didn't. So now I'm going to take an 8 out of this and get a 3, and an 8 out of that and get a 5.
Mm-hmm.
So in the numerator, I've got 1 times x plus 2 times 3. And in the denominator, 5 times 1 times x squared, 5x squared. Now, can I reduce those? Careful.
No.
Why not? Because this x is not a factor of the whole thing. It's not being multiplied by the 2, just by the 3. This whole thing, x plus 2, is a factor, but I don't have an x plus 2 in the denominator, do I?
No.
Yes, factors reduce, terms don't. Okay, let's see here. Still got 16 minutes to torment you, so I plan to. Here we go. R squared minus 11r plus 18. One of my colleagues, when he was retiring, he said, you know, I could have been a dentist, but then you can only torture one person at a time. Okay. So what's the first thing I'm going to do here?
Put the r minus 2/1.
Yes. Actually, yeah, so 1 over that. Yeah, okay. So change division to multiplication of the refliprical. Yeah. And I advise you to do that before you factor, because otherwise sometimes people try to reduce across this division sign and you can't, okay? So now, let's see, -9 minus 2. Oh, sweet deal. My daughter says I'm too old to say the word sweet, but she's not here right now, so. who cares? Right. So the R minus 9s go. The R minus 2s go. 1. Wow. Wow. Is that right? I guess so. Just seems amazing that it came out so nicely. Okay, hang on here. This one. Trying to find. Okay, here we go. B squared minus 5b plus 6 all over b squared minus 10b plus 16 divided by b squared plus 2b over b squared minus 6b minus 16. What are we going to do first?
Flip the second term.
And change it to,
Division, multiplication.
Okay.
yeah. So dividing by a number is multiplying by its reciprocal. So don't just flip it. You got to change the sign as what the operation as well. Okay. All right. Okay.
Yes.
I was thinking about don't make your B's look like 6s, and so then I wrote a 6. 16. Oh wait, 6. So I got a plus. So what's the matter? Oh well. Okay. -3 and -2, I think. And then down here. -8 -2. And then over here, -8 plus 2. And then down here, that. So we've got everything factored. We changed dividing by a number to multiplying by its reciprocal. Now we factor everything. So let's reduce out the common factors. I can take out a b minus 2 and get a 1 over 1. I can take out a b plus 2 and get a 1 over 1. I can take a b minus 8 and get 1 over 1. And I've got b minus 3 over b. Can I reduce these b's out?
I'm gonna say no.
No.
That's a good answer because it is no. Why? This b is not a factor of the numerator. Now, let's say my answer had been something like this. Then I could have reduced those out. But this b is not a factor of the entire numerator. Okay. I almost tricked you, but I didn't. Good, 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 good. Okay. How about this lovely one? Let's see. N squared minus 9 over n squared minus 3n divided by n plus 3 over n squared minus n. The first thing we're going to do here. Say the whole thing now.
Flip and then switch it to division.
It already is division.
Multiplication, my bad.
Okay. Multiply by the reciprocal. Okay. We're going to get you there yet. Okay. Now what?
Factor.
Good job. So like during the test, you want me to sit here and do this? Probably not. Probably not. I get lonely here in my basement. Okay. So difference of two squares, factor out an n, factor out an n, leave it alone. Okay. So now we're going to have a reduction sale bigger than when Nordstrom's left town. You probably didn't even know we used to have a Nordstrom's in Yakima, did you?
No, I did not.
Well, yeah. Lots of.
We had a Bon Marché in the old mall.
Old mall? You mean there was a mall here? Yeah, I know. Downtown was a booming business, but not anymore. Okay. So let's see. We can get rid of a n plus 3.
Mm-hmm.
We can get rid of an n minus 3. We can get rid of an n over an n. And what we got left is n minus 1. All over 1, which is just n minus 1.
Nice.
Okay. Good to go on?
Yes.
How about this one? 7 over 3p cubed times p plus 2 over p. What can you do?
You could switch it to times to multiplication. Well, 7 times p plus 2. Would that work?
Look again.
Wouldn't we have to factor the 3p to the third power first?
Look again. First of all, it's already multiplication, right?
Yeah.
So you don't see it. You were in such a rut there that I threw one at you. I was like, oh, no, I know I'm a tricky guy. Well, we could take the 3p cubed and write it as 3 times p times p times p, but it's not going to do us any good. All we can do is just multiply it together.
Yeah, that's what I meant.
Of course you did. Yes. All right.
Yeah.
That's it. Unless you want to, you could write, 7p plus 14 over 3p to the 4th. But again, so really there's nothing here you can reduce.
Mm-hmm.
And it's already multiplication. Okay. Oh, I think I've tormented you enough for one day. Don't you agree?
No, I think we're good.
Oh, okay. All right.
I think I'm tortured.
You're
Fractions,
tortured. Okay.
fractions
good.
are not my friends, but as you always say, fractions are
That's
my
right.
friends.
That's right. Fractions are your friends. Okay. So I will be back at 1:15. Should you have need of me? Otherwise, I will see you ladies tomorrow morning. Thank you for stopping by. And
Thank you.
you do. You're welcome.